Okay, I am going to first start with this sequence. I think this was the third one that we were given here, and this is that square root of k divided by the natural log of k plus 1. And so um, I was thinking about this, just kind of chunking in some numbers in my calculator, and I noticed that the numerator is always going to produce a larger value than the denominator. So I was trying to think of just the sequence first, like what's going to be the behavior of that sequence. Should be an increasing sequence, and I think that's shown here. Of course, I've only selected the first 58 terms. We could increase that a little bit. Um, and so I thought that in this case, I actually thought that the series the sums would start to flatten out because I was assuming that that distance between the numerator and the denominator would close, but that does not tend to happen. We can see here these are the sums, and we just see that they get very, very large. Just zooming out here to show that growth there. And in fact, as I change in to maybe like 1,000. We'll just sort of look at what happens when n is 1,000 and see about these sums. And now we've got increasingly, large sums once more. Oops, I'm still on 100. So now I'll just zoom out a little further and we can see the same thing. So we see these sums growing and growing, which indicate then that there is no convergence for this series, and so though there may be convergence for this sequence. So that's kind of interesting. I'm going to pause for a second. So when I paused, I switched this series that's plugged in here to this final series. It's the -1 to the k divided by k. So it's kind of like that sequence that we've been looking at a lot, where we have those alternating odd and even terms alternating, and we see that. I'm going to click out of all this stuff. We see that with the purple, where we have alternating positive and negative values, which will eventually converge to 0, as shown on the graph. And if I zoomed out, we would see that more. I'm going to leave it in the zoom frame for a minute, though. What I kind of was thinking about here is wondering whether or not this series does converge. So I'm sitting at the 1,000th term right now, and we see this negative 0.6926, so on. So I was kind of looking at the odds and even terms here, and I was noticing, I'll just start at 10. So I was noticing the 10th term is negative 646,000. The 11th term is a little further away and I'm saying further away from 0. The 12th term is closer than the 11th to 0, but still further than the 10th, if that makes sense. So it's like we've grown further away. This term right here is further away than this 10th term there. So that's kind of interesting, continuing this pattern. The 13th term then is still further away from 0 than the 12th, the 10th, but not than the 11th. So I was kind of thinking about this. If I click the 14th term there, we get this negative 659 value, 659,000. So the reason I was just checking all this was to see if perhaps this is one of those cases where, depending on the kind of way we want to group them, like if we look at just the odd numbered terms and of the series, would they converge to a different value than the even numbered terms? That was kind of my thought. Maybe that was one of those like kind of special cases that was mentioned in that Alcott book. But so I'm thinking about this, wondering what happens is if I increase the n. So that's going to be the next thing I want to test. And so if I do that, and I've increased the n to 10,000, my 10,000th term, I'm going to give it a second to see if it'll do anything. There's a bit of a lag here, but it seems okay. If I throw one more 0 on, I've still got that same value here. Oh, a little bit of a change there. So negative 0.693. If I just to go back, I'm going to show you. I'm touching it like that works. So here we're going to just see if that changes anything. for the 100,000th term compared to the millionth term. I didn't see a change there. So, but this was an interesting one to kind of explore. I noticed one other thing, which is it seems like it's probably just a little too much work for the program to like compute these sums and show the graph. So I'm noticing when I'm putting in really large values for n, I'm losing my graph, which is, kind of a bummer. But let's see if I can bring it back up. It's been kind of strange. I haven't quite figured out what I need to do to get that graph to come back up. I'm not sure what's going on here. There it goes. It just needed some time. So it's back. And so again, it does seem to me I'm going to continue to increase in and watch that guy grow. And it looks to me as though in a similar way that when we were looking at sequences over these last few weeks, and we were sort of looking at with that epsilon strip activity, where we were basically looking at that one line. In this case, that would be the purple, the sequence. We were saying, it looks to be convergent. We can see it, and then we could choose like our different. We could decide how large we wanted epsilon to be, and then determine precisely whether that was true. But I'm kind of using a similar type of thinking here, wondering, okay, well, if the red starts to flatten out, then that should be a good indicator that this guy converges, that the sums converge here. And in fact, it does to this, whatever we said, negative 69 hundredths and some change there. I don't know exactly what that, maybe that's like a common fraction I'm just not familiar with. But yeah, so that was, these have been kind of fun to explore. I found them sort of, I found this to be a nice change of pace from the kind of like the test of convergence and sort of that heavy algebra stuff that we were doing on the previous problems. I just feel like sometimes this has a more, just personally as a learner, like this kind of activity has a little bit more meaning to me than just sort of the test for convergence, ratio test type of thing, which is important to be able to do, but I don't always recall exactly why I'm doing that. I guess that's what I'd say. So I like being able to tinker with it on these kinds of tools or these graphs. So anyway, this was kind of interesting to explore. I enjoyed it, and I hope you guys are too. Thanks.